We have our last set of notes for this next test on 10.3, solving radical equations. And you might wonder, why are we jumping to 10.3? But you'll see it's still solving equations, and it still has to do with radicals or square roots. Let's first look at this first question here. What is the solution to this? So in other words, the square root of what number equals 4? I think we can all agree that, well, that would be 4 times 4, or 16. And a way we can solve equations like this, just like we can add the same number to both sides or subtract, multiply, divide. We even talked about square rooting both sides earlier in chapter 9. We can also square both sides of an equation. And notice when we square the square root on the left, we have just x, and then on the right, 4 squared is 16. So that's what this key idea is right here. It says if two expressions are equal, then their squares are also equal. So if you have a equals b, that's the same as a squared equals b squared. So in other words, we can square both sides. Well, before we square both sides, we have to have that square root all by itself. And so step 1 here would be to subtract 5 from both sides, which leaves us with the square root of x equals 8. Now we can square both sides. So we're going to square both sides, and we get x squared equals 64. Oops, not x squared. Oops, we'll back that up. X equals 64. There we go. On this next one to the right, I'm going to add the square root of x to both sides because we always want it positive. So 3 equals the square root of x. Now we can square both sides, and we get 9 is equal to x. For the next example, it still involves a square root, so we want to get that square root all by itself. So this is where we're at, 16. Now, again, we want that square root all by itself, so we're going to divide both sides by 4, which leaves us with the square root of x plus 2 equals 4. Now, when we square both sides, on the left, that square root comes off, so that leaves us with just x plus 2, whatever's inside the square root is what we're left with, equals 16. Now we subtract 2 from both sides, and our final answer, x equals 14. Squeeze it in there. Now I'm going to have you try some. So if you're watching the video, pause it. Obviously, you're watching the video if you're watching this right now. But pause it. Try these next 3 on your own, and then push play. So we're going to subtract 15 from both sides. Square root of y equals 7. We square both sides, and we get y equals 49. Here, we're going to, well, let's do this. Let's subtract 1 from both sides, and we get negative square root of x equals negative 3. Let's divide both sides by negative 1. So then we have square root of x equals 3. Now we're going to square both sides, and we get x equals 9. And finally, we're going to subtract 7 from both sides. Square root of x plus 4 equals 4. And, oops, weird looking 4. And then we're going to square both sides. Now that we have the x squared by itself, x plus 4 equals 16. Subtract 4, x equals 12. Now, on the next page, we have a square root equals a square root. Well, just like before, we're going to square both sides. And when we square both sides, we're going to end up with 2x minus 1 equals x plus 4. And now we just solve it. So we're going to subtract x from both sides. X minus 1 equals 4. Add 1. X equals 5. Done. Over here, now you try this one. We're going to square both sides. 3x plus 1 equals 4x minus 7. Let's see, I like things positive, so I'm going to subtract 3x from both sides. 1 equals x minus 7, plus 7 plus 7, 8 equals x. Now, these, we're only going to do, we're not doing these. I'm going to take those off. These next two examples are interesting because they're a little bit different. When we square both sides, we're going to get x squared equals x plus 6. So now when we, let's move everything to the left. So we're going to subtract x and subtract 6 from both sides. So we're going to get x squared minus x minus 6 equals 0, because that's the way we solve quadratics. Now we can factor this. So x minus 3, x plus 2, which gives us answers of x equals 3 or negative 2. So we think we're done, but when we have situations like this, you should always check to see if they're a legitimate answer. So let's check. When we check by plugging back in. So plugging back into the original, 3 equals the square root of 3 plus 6, which is the square root of 9, which we get 3. So that checks out. But now when we plug in negative 2 is equal to the square root of negative 2 plus 6, and negative 2 is equal to the square root of 4. Negative 2 is not equal to 2. So negative 2 is not an answer, only 3. Remember, when we take the square root of a number, it's always positive. Only when we had like x squared equals 9 and we square root both sides, then we have to consider the 2 answers. Okay, let's solve this one. So when we subtract 13 from both sides, we get the square root of 5n equals negative 10. So when we square both sides, we end up with 5n equals 100 and n equals 20. Now again, you might have noticed we were squaring a negative here, and that's an issue. A square root cannot equal a negative number, and that is what we had in this line here. So you can see when we check, if we go to check and plug this back in, 13 plus the square root of 5 times 20 equals 3. Well, we're going to get 13 plus the square root of 100, or 13 plus 10 equals 3, which does not check out. And so this one actually is no solution. And you could see right back here, when we had the square root equal a negative 10, that's a warning. So a couple little pitfalls to look out for.